All right, so our last section is actually 8.7, called L'Hopital's rule. And this is the last thing we're going to be doing for getting ready for the AP exam. So what this is going to help us with is when we are taking limits and we go ahead and do direct substitution. So if we look at this first example right here, if we plug in 3 and we plug in 3 in the numerator and denominator, it results in 0 over 0, which is an indeterminate form. So we learned back in the beginning of the year and even last year in pre-calculus, if we get 0 over 0, that means we have to manipulate and do some further investigation before doing the direct substitution again. So like in this case, we would, and hopefully remember this, we would factor our denominator. And we would see that this function x minus 3 over x squared minus 9 actually has a whole at 3. And then you're left with the limit as x approaches 3 of 1 over x plus 3. And now when we plug in 3, we get an answer. So if we were to look at this graph, the function height would be getting closer and closer to 1/6 as x got closer and closer to 3. Big no-no for the AP exam, and I know I talked about it last year in Honors Pre-Calculus if you had me, as well as this year. You cannot say equals 0 over 0. That is a false statement. So if you do write that, you will lose points for that because that is not true. Okay, so you have to be careful with that. So that's why I wrote it as results in 0 over 0 in indeterminate form. This next one here, same thing. If you were to go ahead and try it, actually, why don't you go ahead and try it? I'll pause it. It's a good review for limits, which we'll be starting to review next week. So go ahead and pause this and try this one. Okay, so for this one again, we plugged it in 0 and you got 0 over 0, which is in an indeterminate form. So back when we learned about limits, we multiplied top and bottom by our LCD. Our goal was to get rid of the complex fraction. And then when we do that and we plug in 0, we get 1/4. Okay, so now the issue that pops up sometimes is when we get when we plug in our C value and we get an indeterminate form and we can't simplify it, what do we do? Okay, so back in, again, that chapter, I can't remember what chapter it was. If it was, I don't remember. But anyways, we use the squeeze theorem to demonstrate, so for this problem right here, that the limit as x approaches 0 of sine of x divided by x does equal 1. And remember to use the squeeze theorem. You have this function, you're going to have a function that squeezes around it. So all values are above it, all values, another function where all values are below it. And then as the limit as x approaches 0, that limit of this function that's going between here has to be somewhere between that value and that value. Okay, again, we'll review that next week. But that was how we did find that the limit as x approaches 0 of this does equals 1. The other way is looking at a table. So if we set that up for this problem here, we would have 0 here, and our goal would be to look from the left and from the right of 0 to see what our limit approaches. Okay, so we would have 0.001, 0.01, 0.1 over here, negative 0.001, and hopefully this is bringing back some memories. And that's how we would calculate that, okay? So now the question is there an analytic way to do this instead of looking at the table graph or using our squeeze theorem? And that is what is called L'Hopital's rule. So this is used when you get an indeterminate form, okay? And what it tells us that we can do is if you're asked for the limit as x approaches a of a function divided by a function, you can actually use the limit of each function's derivative, okay? So what you'll do is you'll find your derivative of the numerator, you'll find your derivative of the denominator, and you will take the limit as x approaches a of both of those and divide them, and it actually ends up equaling the overall derivative. So let's look back here at the one that we worked with in the beginning of the year. So the derivative of sine of x, so let's say f of x equals sine x. The derivative of that is cosine of x. And then if g of x equals x, the derivative of that is just 1. And so this is going to equal the limit as x approaches 0 of the derivative of f of x, which is cosine x, divided by the derivative of g of x, which is 1. And if you plug in 0, you get 1. Okay, so it can be a lot faster than, searching all over your calculator, plugging things in, adjusting your tables, looking at your graphs, all that. So on the AP exam, if you are using L'Hopital's rule, you do have to go through this formal process of showing that your results are, it's in indeterminate form, and you'll need to say, therefore, L'Hopital's applies, and then you would go through and do that process. So why don't we do that on the next one instead of reworking this problem that I just kind of worked through for you already, okay? Another thing before moving on, it is important that you can do L'Hopital's rule more than once. So let's say you find the derivative, and when you do the direct substitution, to find your limit, you still get it in indeterminate form. You can go ahead and do the derivative of the numerator and denominator again, okay? Okay, so let's take a look at this one. It says to find the limit as x approaches 4 of 3x minus 12 over the cube root of x plus 4 minus 2. So when we plug in 4, in for x, you get 0 in the numerator, and when you plug that in here in the bottom, you get 0 in the denominator. So what we would do, remember, you cannot write equals 0 over 0. You don't want to lose points for that. So you need to say results in 0 over 0, an indeterminate form. Therefore, L'Hopital's applies. So what we're going to do is we are going to find the limit as x approaches 4 of the derivative of our numerator, and the derivative of our numerator is 3 over the derivative of our denominator. So if you need to do some work off to the side to go through that, so let's say we're doing f of x, if we just assign that as g of x, so you just always have to make sure you're being formal with everything if you're writing it down. Because if you write down stuff that's incorrect, that's where you'll lose points. You don't want that. So if g prime will give us, using our power rule, so 1/3 x plus 4, 1 less than 1/3 would be negative 2/3 times the derivative of x plus 4, which is 1, and then the derivative of 2 is 0. So the derivative of our denominator is 1/3 x plus 4 to the negative 2/3 power. Okay, so even before we do this, if we want to move things around to get positive exponents, before we do direct substitution, 3 divided by 1/3 is 9, and then bring your x plus 4 to the negative 2/3 up top. And remember, when you have a coefficient in front, technically that can be in front. So you get 9 times the limit as x approaches 4 of x plus 4 to the 2/3. When we do direct substitution here, and you plug in 4 here, you get 4 plus 4, which is 8. Now remember, you can square it first and then take the cube root, or you can take the cube root and square it. So I'll take the cube root first. So if you take the cube root of 8, it's 2. 2 squared is 4, and this will equal 36.